Welcome to the Quixxi tutorial for the automated vulnerability assessment on iOS and Android. Create the app in the Quixxi home screen by clicking the plus sign. Enter a name for your app. Opening the newly created app will give you a view of the Quixxi app dashboard. Click the Assess Now button under Security. Select the APK or IPA file by dragging and dropping, and click on Next to initiate the upload. Once the scanning is complete, the Quixxi automated vulnerability report is generated. Here is a view of the complete report. This includes the Quixxi vulnerability rating, followed by an overview with the app details and threat count. The report also lists the threats verified by the app. The green ticks are for past and cleared vulnerabilities, while a red tick indicates a vulnerability threat alert that requires immediate attention. You can also download a PDF version of the report from the same page. Switch versions of the app to access Android or iOS reports. Repeat assessments are easy for apps created on Quixxi. To accomplish this, click on the Assess Now button from Security. Let's take the original unprotected APK, the one obtained from Android Studio. We will now decompile this APK using an online decompiler like the one freely available on javadecompilers.com. The APK is then uploaded and decompiled. We will search the main activity file, so let's open com/example/quixxi/android test app. As evident, the main activity of this demo application has been decompiled with a very high grade of accuracy. With such a file, the possibilities for hackers are limited just by their fantasy. IP theft and/or tampering and/or malware insertion within an app identical to the original one. Every variable and every method is totally recognizable and modifiable. The overall app flow can be altered too, because each part is easily understandable. In a few clicks, your app can turn into something very different from your original idea, with a danger for the user and a damage to your reputation. The solution to all such scenarios is Quixxi. Let's take the original APK already obfuscated through ProGuard. As usual, let's drag and drop this APK into the box, and let's configure the security options as required by the particular app. Once done, just wait for the Quixxi App Shield to be applied on top of your provided APK. As soon as the compilation is over, let's click on the report section to download and extract the unsigned protected app. After the app signature is applied, our original APK will be transformed into a signed app secured with the Quixxi App Shield, ready to be installed on mobile. It is now interesting to decompile this last APK exactly as we did before and check the difference. We choose and upload the file as before, and we go through the same folder path to reach the main activity file. First of all, as you can see, alongside the main activity itself, there are now many more files than before. Let's enter the main activity. As you can see while scrolling down the page, everything has been reduced to a series of random characters. Quixxi drastically destroyed the code readability, making it almost impossible to tamper, reuse, or be injected. Specifically, let's have a look at the first decompilation, and let's select a method declaration like onRequestPermissionResult to do a side-by-side comparison. We can see that the hard-coded strings were transformed into gibberish sequences, and that the method calls have been randomized so that it's not anymore possible to understand the order of the calls, preserving the original app flow. In this video, we are going to see how to detect app tampering with Quixxi. The developer creates the demo project on Quixxi portal. And after clicking on Protect Now, he drags and drops the demo.apk to be secured. Quixxi will allow a wide customization of the security options. Once done, we click on Next to apply the Quixxi App Shield. At the end of the process, in order to download the protected APK, the developer will click on the Report section. When downloading the protected app, a pop-up will remind the developer to sign this secured APK. The APK is now ready to be published on Google Play Store. The hacker downloads on mobile the sample app, My Buttons, that the developer previously uploaded on Google Play Store. This is the original app, so it will open. Now the hacker will start the process to reverse engineer it. First, he will retrieve the APK from the installed app using, for example, APK Extractor. Now this app will be copied on the laptop and renamed as app-to-tamper.apk. The hacker will start taking the framework resources from this APK. After this, he will decompile the app. At the end, he will get an app-to-tamper folder. Now he enters this folder to edit the Android manifest to add a permission not originally requested by the app developer, for example, the one needed to enable Bluetooth. After editing the code, he will repack and produce the tampered app.apk. Then he will optimize the rebuilt APK with zip-align. And finally, he will sign the tampered app so that it can be installed on mobiles. Now let's see what happens when the final tampered app.apk is installed on a mobile. As soon as the installation is over, when we try to open it, we are bounced because the tampering is detected. On the developer's side, the detection of the tampered app will be logged in the Threat Log tab. He will be able to see the details of the illegal user, the confirmation that the app wasn't downloaded from the Play Store, and the reason for its termination.